On point-to-point links, a proposal agreement handshake sequence is used by Rapid Spanning Tree to achieve faster convergence. So Rapid Spanning Tree uses this to quickly transition ports to the forwarding state, whereas 802.1d was just waiting for timers to expire before ports were set to the forwarding state. In this topology, if the link between the root switch on port 0 and port 1 on this switch came up, they would send proposals to each other. Both ports are put into designated blocking, and they both send a Rapid Spanning Tree BPDU with the proposal bit set. Now this relies on a new BPDU format, which contains a proposal bit in the BPDU. So additional information in a Rapid Spanning Tree BPDU has been added. We have the proposal bit, we have the port role, we have learning, forwarding, and agreement bits, as well as a topology change bit and topology change acknowledgement bit that are part of the Rapid Spanning Tree BPDU. So essentially what happens is when the port comes up, the switches send proposals to each other saying, I want to have the designated port on this segment. However, because bridge A, this switch here, receives a BPDU indicating a superior path cost, in other words, a better path is found via the root switch than itself, it immediately knows that port 1 is going to be its new root port. So it knows straight away that this port should be its root port because this port has the best path back to the root switch. In other words, a superior or better or lower path cost. Bridge A, in other words, this switch, starts a sync to ensure that all of its ports are in sync with this new information. A port is in sync if it meets the following criteria. It is in the blocking state, in other words, it's discarding, or it's an edge port. So in this example, port 2 is an alternate port, port 3 is a designated port, and port 4 is a edge port. So port 2 and port 4 already meet one of the criteria listed above. It's in the blocking state or it's an edge port. So to be in sync, bridge A must block port 3 and assigns it to the discarding state. Now that all ports are in sync, bridge A can unblock its newly selected root port and reply to the root with an agreement message. So basically a proposal is sent from the root to switch A. Switch A agrees that this is the best path back to the root. It blocks all ports or makes sure that they are in sync because they're edge ports, and then sends back an agreement. As soon as that happens, the ports can be unblocked. So bridge A can unblock its port and replies with an agreement message. Once the root switch receives that agreement message, it can transition immediately to the forwarding state. So proposal, agreement, unblock port. In other words, set it to the forwarding state. Now that happens very, very quickly. Now by the same token, switch A can send a proposal to this switch. So this process continues. Proposal to this switch sends back an agreement, this port can go to the forwarding state. This happens very quickly because it doesn't rely on timers. This wave of handshakes propagates quickly towards the edge of the network and quickly restores connectivity after a change in the topology. If a designated discarding port does not receive an agreement to its proposal, it slowly transitions to the forwarding state using the traditional 802.1d listening learning sequence. This could happen if the remote bridge doesn't understand Rapid Spanning Tree BPDUs or if the remote bridge's port is blocking. So in this topology at the moment, shows spanning tree, gigabit 01 is a designated port in the forwarding state, but it's a shared port. In this topology, gigabit 00 has been shut down, so the root port on switch 3 is gigabit 01, and the alternate port is gigabit 02. But if I no shut gigabit 00, so I've enabled this port again, show spanning tree, notice gigabit 00 is the root port of switch 3. This port is now the designated port but is in a blocking state. 02 is in the blocking state, backup port. On switch 2, the status has changed to blocking, because on this segment, this is the best port to use to get back to the root bridge. However, it takes longer for this process to complete than it would be if it was a point-to-point link. Shared ports take longer to converge. So let's do that again. I'll shut the port. So gigabit 00 is now going to be shut down. Previously, gigabit 01 on this switch was the alternate port. Now it's the designated port, but it's blocking. Still blocking. Show spanning tree on switch 3. Notice alternate port is blocking. Root port is forwarding. Now the port is in the learning state. So traffic is still being dropped on this port, even though this is the port to use to get to the root bridge. Now it's forwarding. It can take 30 seconds on a shared port because we're using traditional 802.1d listening learning sequences on that port. To use proposals and agreements, the ports need to be configured as point-to-point ports, or need to negotiate to use full duplex.